In this video, you will be learning about vertex form for a quadratic function. So make sure that you did yesterday's assignment so that the vocabulary that I use is not unfamiliar to you, because we covered a lot of vocabulary in that lesson. Yesterday we talked about standard form, which is the form y equals ax squared plus bx plus c. Its key feature being that the constant term is your y-intercept all the time. Which I spelled wrong. Intercept. So today we're going to be talking about vertex form. So if you have this graphic organizer printed, please get it out. If you did this graphic organizer in your notebook, we're going to add on to vertex form. At the least, when you submit your picture of your notes today, it should have vertex form at the top with today's date, which is 9/30/20. So let's go ahead and talk about this important vertex form. As you can imagine, the fact that it says vertex form should mean that the key feature will be that the vertex is easily identifiable. Vertex form is y equals a times the quantity x minus h squared plus k. And I know that seems weird because we have h and k. We haven't talked about h and k. But let's talk about things we already know. We have an a over here in standard form, and we talked about the significance a plays in whether the graph opens up or down. We talked about that if a, the leading coefficient of the quadratic term, if that a value is negative, then our parabola would always open down. And then if our a value is positive, it will always open up. The same is true about a here in vertex form, as it will be tomorrow when we cover factored form. The a value always tells you the direction of the opening. The sign will indicate the direction of the opening. So again, if we have a positive a, it will open up, and a negative a means it opens down. So that's an important feature about vertex form as well. The new most important feature has to do with h and k. So what we know is that in this form, our vertex is the ordered pair h and k. H is simply the x-coordinate, because we know we talk about x and y being points on a graph. We define them as h and k because h is horizontal. It has to do with the horizontal shift, which we will talk about next week when we get into transformations of quadratic functions. And k, I'm really not sure why they chose k, but k actually gives us a vertical shift, which again we'll talk about. But it means that from the original function, y equals x squared, we can change the vertex and identify it very easily. Over here, it's not easily identifiable. Here, we simply pull the h and the k from this function. So as an example, if I were to give you y equals the opposite of the quantity, x plus 2 squared minus 3. Things I'd want you to recognize. If we compare it to this function, I want you to think this was minus h. So what would h need to be for this to have changed to a positive 2? Well, that would mean that that number, that h value, is actually a negative 2. I'll explain that in a second. The k value is positive k, but now it's a negative, so it's going to be negative 3. So you're probably wondering, like, how do I get negative 2 and negative 3 when up here it had a plus 2 and a minus 3? Well, if I were to take this value here, by the way, my a value is what here? It is a negative understood 1. And if I plugged in into the formula x minus my h value, which is negative 2, and then inserted my k value of negative 3, because we don't need plus a negative 3. We can just write minus 3. The fact that I had minus negative 2 means it's really addition. So that's where we get x plus 2. So what does that mean you need to do? Simply remember that to find the vertex, we need to switch the sign of what we see here but keep the sign of our k value. Okay, so we're going to switch keep. I'm going to say that over and over as we practice. Switch keep. So that's one example. So I'll call that example A. If I have the function y equals 3 times the quantity x minus 1 squared plus 4, then again, to identify my vertex, I'm simply going to switch keep. As in, I'm going to switch the sign of what I see here and keep the sign that I see here. So if we switch this, it looks like a minus 1 or negative 1. If we switch to negative 1, it's going to be a positive 1, but we keep the positive 4. And we know that it opens up because my A value is a positive 3. That's going to be important for our Delta Math assignment today. Because this was negative, it's going to open down. So I'll come up here and beside the vertex put negative 2, negative 3, and we know it opens down. For this one here, my vertex is positive 1, positive 4, and it opens up because my A value is a positive 3. We'll do one more example. If I have negative 2 times the quantity x plus 5 squared minus, or I'll just do plus 7, then my vertex would be what? Switch, keep. So this plus 5, I would write that as an h value of negative 5, and my k value would be keep positive 7. Because my a value is negative, I know my graph will open down. So those are the key features of vertex form. We can understand the direction of the opening, and we can understand how to identify that vertex, but remember that we switch keep. So if you're still listening, please make sure you put boxes around these. And down at the bottom, put your favorite sport. Just right here, real little, your favorite sport. All right, so now that's all the notes we have for today. We are going to go to the Delta Math assignment, and I'm going to practice a few with you. So when you open up Delta Math today, remember your cumulative review from Friday has a due date of tonight at midnight. So please make sure if you have not already, complete that assignment and submit it along with the work. Remember that if you do not submit work, then we do not give credit for the assignment. Here, the key features in standard form, there was the video that I referred to in the announcement today to make sure that you watch the video with all that vocabulary and that you have completed this assignment. That is also due tonight. And then you also have vertex form of a quadratic function, which is 15 problems. And like I said, don't really need to show work. We're just going to answer the questions because identifying the vertex is so easy. So this is problem 1. Your job is to identify the vertex. Please note that I did have to create these questions, and I did create multiple choice questions, so you do not have the option of clicking watch help video or show examples. But you can refer, I'm leaving this open, you can refer here to these notes that we have as your work, okay? Then I already did 3 examples for you where we just switch keep. So if we take a look at this one and we switch the sign here, that means we're looking for a negative 5. So I'm not going to choose these two, but we keep the sign here, so I'm looking for negative 5, negative 3. It's that easy, guys. So you're going to go through and answer each of these. I'll just do the last one with you. Identify the correct vertex of the equation. Switch, keep. So if I see a negative 5 or minus 5 there, I'm going to switch that to a positive 5. So it's going to be one of these two. I keep the sign here, so it'll be positive 5, positive 4. That's it, guys. So I hope you enjoy this easy assignment. That's it, because I'm going to do a couple of these other ones, but that's all you have to do for these in particular. So let's go down here and take a look at these types of problems. On these problems, I'm asking you to identify the equation that would match the graph. So if I notice, the first thing, it opens down. So that's the first thing you should notice is, oh, it opens down, which means my A value should be negative. So that means I would not choose one of these two graphs or equations, functions. I do want my negative here to be in front of my quantity squared, so I know it's one of these two. But now we have to identify the vertex and then make sure it's switched keep when we plug it in. So if I have, there's two ways you can look at it. You can just identify it first, so it's -5, -1. If my vertex is -5, -1, I'm going to write this over here. If it's -5, -1, I should see +5 -1 in my equation because I switch keep. So this would be the correct response. That's one way to do it. I'm also going to show you that if you wanted to, you could if you like, I know it's one of these two because it opens down. Let me switch keep my vertex and see if it matches this vertex. So I could do -5, -1. Does that match? -5, -1. Yes, it does. Okay? So that's another way you can look at it. I'll do one more of these with you. These do have help videos if you needed to. Let me get one that opens up. Here we go. All right. So again, here for 14, guys, this one here, it is an upward opening graph. Remember, if it opens up like a cup, then my A value will be positive, or just think, I also said think about a smile and a frown. If you are smiling, then you are in a positive mood, so you would be looking for a positive A value. Notice they all have positive A's, so that means we're going to have to correctly identify the vertex. So again, I can go -5, 4. And so again, if I have -5, 4, if you want to show work, that's what I would do. Probably just write down the vertex, -5, 4, and then look for the one that is switched. So I want to look for +5, +4. So +5, +4. Oh, it's that one. Okay. Again, you could just say, okay, here my vertex is switch keep. That would be 5, -4. Is my vertex at 5, -4? No. Over here, if I switch keep, my vertex is at +5, 4. Is my vertex at 5, 4? No. So it's not that. So you can use process of elimination like that. Or again, you can simply identify it and remember to switch keep when you put it back into your vertex form of a quadratic function. All right, short, easy lesson today. And I hope you enjoy that one. And let us know if you have any questions. Thank you very much.